This video focuses on Bitwatcher and Bitcheck. There's a new implementation added. Originally I was just going to keep this here temporarily. Bitwatch and Bitcheck are pretty much the same thing. Bitcheck is the actual command that runs Bitcheck, and turning on Bitwatch uses embedded flags within the library to call it at specific times, most generally being when you write to the eeprom. In order to do this, I've created a hash of a hash, and I've got the convention right here, and basically what I do is I load in all the unknown memory addresses that we haven't figured out yet with the current values that they have. So each time that you write to the eeprom or run a cat command, it'll recheck these values to see if there were any changes, and it will then tell you what you had executed to bring about that change. For this example, I've changed on 0x55 bit 4, I've changed it to 1. So it's going to detect that a bit has changed when we run the software. I can do it simply by running bitcheck, which will run the command, and it's going to find it. And you can see here that it found that at memory address 55, bit 4 is 0, and it was supposed to be 1. These are actually backwards right now. I'm going to change them. It is 1, was supposed to be 0. There's no last modification when you just run it from the command line because I haven't actually ran a command. So what I'm going to do is I'm going to run a command first. There's going to be get cat get mode, and you see the mode is USB. I can also do set NB on, turns the noise blocker on, set NB off. Now, if I use Bitwatch, the program will now automatically watch for changes based on the hash. If I now run cat get mode, and remember how I have changed bit 55, memory address 55 bit 4 to purposely find an error. So I do a cat get mode, and I see here that I get that the change was found in the memory address. Tells you what the packet was that was sent out and who called it. Again, I will try set NB on. You can see right here that it threw the alarm. There's the packet and who called it, and even write block has the function too. So restore 005F, and you can see even restore eeprom will call it. Normally, if this were correct, it wouldn't find any change, it wouldn't report anything, and if you called it from the command line, it would simply say that it was okay and there were no changes made.